Greetings viewers, today we will journey into the hidden world of ants and see these small yet mighty insects up close. With their tireless labor, ants touch nearly every ecosystem and play a fundamental role in maintaining a balanced environment. Over the next 30 minutes, I will do my best to convey what is truly an astonishing society that thrives underground, out of our sight. Let us begin our exploration. Ants have roamed the earth for over 100 million years, and today there are over 10,000 known species. They occupy nearly every land habitat from tropical rainforests to Arctic tundra. But due to their small size, the incredible feats of ant societies often go overlooked. With their immense numbers, powerful cooperation and specialized roles, ants hold more influence over the planet than one might think. I hope to shed some light on their hidden achievements and importance. First, let me introduce you to the typical ant you might encounter. Worker ants range from 1 to 15 millimeters in length on average, depending on the species. Their bodies are segmented into a head, thorax, and abdomen. Ants possess elbowed antennas, simple eyes, and strong jaws adapted for specific tasks. They communicate using pheromones, touch, and sound. While short-lived as individuals, ants live in long-lasting family colonies that can persist for many years. Ant colonies are made up of queens, reproductive males, and wingless female workers dedicated to their nest. A single colony may contain one queen or multiple queens, thousands of male and female reproductives, and hundreds of thousands to millions of workers. This diversity of roles allows for a cooperative society where each member contributes to the greater good. And cooperation is truly the ant's superpower, achieving more through teamwork than any individual possibly could alone. The foundation of ant colony organization is the nest. Nest locations vary per species but usually involve underground burrows, woven carton nests, or built-up mounds. Some foliage or canopy ants construct arboreal nests high in trees. No matter the design, ant nests provide a safe shelter where queens lay eggs and workers tend developing young at different immature life stages. Complex tunnel networks allow rapid movement of ants throughout. Internal environmental controls keep optimal conditions for brood rearing. Now let's observe a typical ant nest up close using a camera-mounted microscope. What first comes into view are the comings and goings of small black worker ants along winding dirt ramparts. These ants likely collect soil pellets and use their jaws to weave rear galleries. Look closer at the entryway, see those antennae sampling the air? Scouts check for intruders or recruit new laborers as needed. Nearby, we spot larvae being nurtured in nursery cells. Their caretakers methodically distribute food regurgitated from their crops. Truly, ant nests are alive with activity even out of direct sunlight. Once outside the protected nest, worker ants display diverse roles tailored for various tasks. Some, like janitorial sanitation workers, remove debris, casualties, and waste. Nurse ants handle brood care underground. But the bulk of workers focus outside duties that sustain the greater colony. Which brings me to the incredible strength of numbers that is ants. Take foraging, for example. Worker scouts continuously explore outward from the nest, leaving chemical scent trails to mark good food sources and guide recruits. When encountering prey, carbohydrates, or protein, they recruit abundant followers rapidly. You wouldn't believe how fast barren soil can transform into a bustling highway of ants upon discovery of a spilled sugary liquid or insect carcass. These observable trails attract dozens, then hundreds, growing exponentially until perhaps thousands temporarily join the effort. It's quite the clustered parade line. This recruitment behavior allows ants to quickly capitalize on ephemeral resources in large amounts that a single ant could never carry or finish alone. Through this cooperative foraging lifestyle, ants procure massive quantities of sustenance collectively. Field studies have estimated one mature leafcutter ant colony harvesting over a metric ton of vegetation annually by coordinating tens of thousands of leaf carriers. Now that's teamwork on an unbelievable scale. Leafcutter ants present a prime example of ant task specialization at work. Scout ants locate suitable leaves to fell with their strong mandibles. Then, worker reinforcers guardedly transport leaf fragments, which can be up to 150 times their size, back arduously to the nest over long distances. Meanwhile, vegetation clippers harvest plant material for return transport. Soldiers stand guard against predators. And load bearers aid by lifting sections onto conveyor lines of additional carriers, continuing transport in an assembly line fashion. With such role partitioning, these ants defy what seems possible for their size. As the leafcutter ants carry pieces meticulously back, I'd like to call your attention to an unusual behavior. Notice how workers occasionally stop and engage in antennal interactions along the way? Researchers believe this tandem running allows experienced load bearers to guide naive recruits directly back to the nest. Chemical signals may also be shared to reinforce the trail path. How remarkable that ants have evolved cooperative guidance like this. No wonder their teamwork is so streamlined and effective at maximizing leaf capture efficiency. Upon reaching their fungus garden underground, leafcutters deposit vegetation clippings to cultivate specialized fungus as a nutrient crop. This agriculturally developed symbiosis provides the colony's primary diet, leaving plenty of waste and spent leaf matter behind to nourish mycorrhizal allies. Scientists estimate that a single mature leafcutter society may process over 1 ton of vegetation every year through collaborative cultivation efforts led by the queen and her worker force. Their contributions regenerate surrounding forests while sustaining the colony's growth. Truly, ant abilities defy expectations given their size. Another famous example of ant industriousness lies with honeypot worker castes equipped to store liquid nourishment. When times are scarce between foraging expeditions, these honeypots expand abdomens full with sugars, amino acids and triglycerides that form the colony's emergency rations. Their engorged bodies become living food storage tanks nourished via social feeding offered to hungry nestmates on demand. Over millions of years, ants perfected this internal logistical strategy to endure lean periods, offering a tangible survival advantage. It's sure ingenious how evolution shapes specialist jobs to benefit the community like this. At the end of each collection marathon, laden scouts retrace trails back to distribute gathered goods amongst the populace. Workers receive nourishment voluntarily given upon request from the living pantries or directly by trophylactic mouth-to-mouth food exchange. The brood, queens and every member of society receives ample material to perform their designated duties through this dutiful social provisioning network. And as harvesters tire, their nourished nestmates replace them on future shifts, enabling perpetual labor rotation sustaining the anthill's prosperity. The majority of ants spend their lives subterraneously within tunnels, expanding their colonies while caring for young, tending fungus gardens or maintaining infrastructure. But certain tree-dwelling species overlay inviting ant farms beside trunk highways, exposing brood in hanging baskets. Commonly known as weaver ants, many build living nest constructions that would make any house proud. Watch as these tiny caretakers embroider silk curtains and living room additions using chewed plant fibers as raw material. Their woven citadels grow generation after generation through communal handiwork. Truly spectacular architectural achievements considering their architects measure just millimeters in stature. As we follow workers carting debris and material fragments outward from nests established both above and below ground, I'd like to reflect on the immense tidying services ants provide. Every day, they efficiently remove dead insects, plant detritus, used larval skins and colony waste while aerating soil simultaneously. Ant galleries enhance drainage and root penetration as their passageways gradually expand. The constant shuttling causes soil crumbs to filter downward like a natural sifting process, improving granulation over seasons of annual reconstruction projects. Ants harmonize habitat and boost fertility too through fetching nutrient-rich deposits from hidden fungal fields below surface levels. Their cleanup crew role keeps the external environment spick and span, better facilitating plant and tree growth across communities. Speaking of plant life, many flowering species require ant cooperation for survival and broad distribution. Some flora have evolved sugary secretions called extrafloral nectaries that attract ants as drinkers and bodyguards. In turn, ants defend producing plants from herbivores and compete less for resources, forming mutualisms. Other ant symbionts spread seeds by scraping out pulp left in abandoned seed casings, accidentally conveying these duranta travels for underground cache placements. Germinating seedlings then sprout from refuse piles, benefiting plant populations. Still more ant varieties feature co-evolved seed dispersal mechanisms that hitch seeds inside a worker's plumage for rides direct to new prosperous growth sites. Many trees couldn't persist without ant assistance distributing their offspring, maintaining forests for wildlife and people alike everywhere. The incredible teamwork and contributions of ants flow all the way up food chains, fundamentally supporting entire ecosystems. For example, certain woodland ants play an indispensable dietary staple for insectivorous birds, from scratching woodpeckers to seed-eating sparrows. Ant prey also bolster predators like spiders, reptiles, amphibians, and even other ant competitors. So while ants inhabit unseen realms, their industry nourishes countless organisms both seen and unseen across all habitats globally. Their role as agent recyclers, engineers, and couriers powered by colony cooperativeness proves pivotal for environmental balance on a grand scale. Well, friends, we've come to the end of our journey into the astonishing world of ants. I hope you've gained an appreciation for these tiny yet mighty insects and their crucial roles maintaining healthy ecosystems. Their immense teamwork through division of labor is truly nature's formula for success. I'd like to thank you for spending this time with me exploring ant nests, foraging behaviors, intricate societies, and so much more. If you found this video educational or entertaining, please consider clicking the subscribe button below. Your support helps my channel continue producing wildlife education for curious minds of all ages. Speaking of support, this video was funded in part through the generous affiliate links in the description box. Whenever you shop using those links, a small percentage comes back to help cover production costs so I can create more videos like this one. Every little bit makes a difference, so please explore those links when doing your online shopping. And finally, I welcome any thoughts or feedback about ways to improve future videos. What topics would you like to see covered? Please leave a comment below. I read them all, and your comments help me tailor programming to viewers' interests. Thank you again for joining me today, and I hope to see you on the next episode of Ant Explorers. Farewell for now.